All right, so today I would like to move on with a more object equality lecture, and we'll definitely do more about the conceptual idea, how you can design the equals method. Most of it is actually quite standard, but we need to understand why the standard works that way. And then we got to look at the some JUnit test assertions if we have time, but that's kind of the plan. All right, let's have a quick recap. Oh, before that, let's now take a look at some reminder. All right, so for your coming reading week, I'm going to hold some special office hours. It may not be the normal ones like a Monday, Tuesday, Thursday. I'm going to reach out to you by e-class announcement. I'll make some time. And I would suggest during the reading week, apart from other commitments you might have, you may definitely want to work on lab number 2. It's a very important lab to get you prepared for programming test number 2, which is also coming after the reading week. And then if you want me to go over your answers about written test number 1, yes, reach out during the reading week. And also, more generally, after programming test number 1, if you found yourself maybe still lacking some basics about programming in Eclipse or of OOP, if you find the need, also reach out to me during the reading week. We can do some little exercises together, one-to-one, and then I can also make some suggestions to you how you can improve. But you just got to reach out. Otherwise, how can I know what your difficulty might be? And there will be a bonus opportunity coming. What I normally like to do is I will send out some anonymous e-class survey about how you think about the course so far. If you think that's good, tell me about it. If you don't think that's good, also tell me about it. I will be very interested in hearing. And if there's any adjustment I can make after the reading week, I'll try. If not, maybe for future students, right? Either way, it's going to benefit the course. I'll reach out to you about this bonus opportunity very soon. Maybe tomorrow or maybe early on Monday. Okay, I'll let you know. All right, guys, any question about the course in general? Yes? Yeah, so programming test 1, I'm going to gather together with the TA, maybe right after the Thanksgiving long weekend, maybe on early Tuesday. But I already spoke to another TA to start doing some automatic grading right away, maybe tomorrow. And then there could be quite a good number of a submission that we have to look into manually, which we don't normally do for labs. But for programming tests, we'll try to look into your submission to see if there's anything we can do to give you partial marks. May not be too much scope. We'll still go with what the programming test 1 guy says. But anyway, so you're going to hear from me about a result, hopefully within a week after the reading week. I'm hoping. Definitely before your programming test 2. You definitely need the feedback. Yeah. It's a fair concern, but I'll try my best. All right, guys, any other question? All right, so why don't we move on a little bit about recap, and then we'll move on with the new material. So last time, we basically finished discussing the JUnits, the JUnits and also regression testing lecture. Especially we talk about the example where the way you design your test really depends on what the expectation is. Do you expect some exception to occur or not occur? It's going to impact where you put the fail assertion. Either you put it at the end of the try block or you put it in the catch block. It depends. Right? We talked about the reasoning throughout the lecture last time. So please review if you still got confusion. And after the whole discussion, we concluded the lecture by 2 exercises to compare console error messages versus exceptions. Right? We talked about it. And also we talk about, can you reduce the number of try and catch block about the 2 phases of the test, right? We also talk about it. So I would suggest really go over the exercises to see if you're able to also express the ideas yourself. That might be something you can expect more during the exam, the final exam, because that's going to be cumulative. And the final example we spoke about in that lecture was how you can use the loops in JUnit test. I would say you're not really required to write any JUnit test cases for this course, but at least you should know how to read them. I think it's a very common practice for people when they write JUnit test cases, they try to somehow automate certain setup by using a loop, like what we said in this example here. You can just be creative about how you tested multiple values in different assertions, right, by using a loop. All right, so that's basically what we spoke about that lecture. And we started the discussion about a new lecture, which I'm going to continue today. That's about the object equality. So by default, if you got a class called point version 1, You only got X and Y attributes. And you got some constructor here. That's it. Very simple class. We don't have any explicit declaration of the equals method. However, as soon as you have this class defined and declared, you can use the equals method right away, even though you didn't declare that explicitly. So the idea would be, there is a class called object class. And this is why I showed you the slide last time. I also showed you the diagram. So these are the two lines you want to know from now. So there is a class called objects in Java API. You have no control over it. It's been defined there. So every method in the object class is automatically available in every class you define on yourself. That's what we call inheritance. But we're going to go a little bit more into inheritance after the reading week. But for now, you just need to know that in the object class, there is a method there called equals. It's like an accessor. It's going to take some objects as parameter over here, as you can see, and it's going to return a Boolean result, right? It's an accessor. And what that is going to do, we're going to discuss in detail today. There are different phases that we need to discuss in detail. But let me remind you about this diagram over here, which is pretty important, right? So think about the object class is at the top, always. And then the equals method here is just one of the methods you can always make use of, even though you don't really have that declared in your class. It's just inherited by default. And the default implementation, which I showed you in the Eclipse last time, you can also reproduce that exercise yourself. The equals method, by default, is only going to compare the references between the two variables, right? Because they're both reference variables. You're just comparing their address. So for point v1, in this case, as we'll see today, whenever you're trying to call equals method on point v1 objects, it's going to invoke this version of the equals method. That's default. On the other hand, which we're going to see today as well, if I create another version 2 point, let's call it point v2, that class over there has explicitly declared the equals method. And we call this overridden method, or redefined more intuitively, whichever way you like to call. And once we got this equals method overridden, there is certain pattern that we have to follow as a standard. And as we'll see today, this part over here is the last phase, will be the creative part that you as a programmer has to fill in. That's something we'll see today. But typically, you just compare attributes between the two objects. That's something we'll run into detail. And then, and some very curious mind actually asked me after class last time, what does this really mean? Looks like a casting. But maybe what you learned from the first year was you might just put something like a double over here rather than a class. You might be wondering. That's something I'll give you a little bit of intuition. The detailed discussion about something like a casting here will have to wait until we do the inheritance lecture after the reading week. But today, I'll try to give you some example just to demonstrate the idea so you get some intuition. All right, so recap. We got default version here from the objects. And this object default version of the equals method is going to be reused in this class over here. However, whenever we want to compare objects of this type, because they have their own version of the equals method, that's the version we're going to use instead. So when you do the code tracing, that's the pattern we're going to see. All right? Any question from the recap over here? We good? Alrighty. Let's now move on a bit. Okay, so let's now do something simple just to warm up. Okay? And all the examples are on the slides. And also, I made the source code available on the lecture site. And it's your job to really dive into the code details and just make yourself, really understand every line of code. That's the best way to get yourself prepared for assessment. Also good for your learning. All right, let's now talk about point v1 still. Right? You can see, again, this class here has only x and y, and also point v1 constructor. No explicit declaration of the equals method. That means whenever we want to call the equals method on the point v1 object, it is going to invoke this version that's from the object class, right? That's a simple case. Let's do some jitter assertion and do some tracing just to warm up, and then we'll see the more complicated case for version 2. Let's say here we got some string object over here in the first line, right? So we got s, which is pointing to some objects. For simplicity, I can just say 2, 3, right? So you just know that string is a reference type, 2, 3. That's what we have. And then in the next 3 lines, we're going to create 3 objects of type point V1. Right? I got P1, P2, P3 here ready. So for P1, it's going to be 2, 3. For P2, also 2, 3. For P3, 4, 6. Right? You should have no problem tracing this. Let's now try to answer the question one by one. For now, let's just focus on more about the Boolean expression. We can use assertions maybe a little bit later. Okay? Let's go one by one. Let's see. What if I say P1 equals P2? Should be false, right? Different objects. What about P2 equals P3? Also false, right? Now, what about P1 dot equals P1? Right? So this one gets a little bit, you really need the knowledge from last time and what I just recapped. When you say P1 dot equals P1, right? The way it's going to work goes like this. Because we know that P1 over here is a point V1 object, as you can see, right? You can also see that from the title of the box over here. That means it's going to call the version of the equals method from point V1. But currently, there is no version of equals method in point V1. What it will do is going to its so-called superclass in the object and call this version instead. Okay? And this version here will just be doing this equals obj. So now it will be as if we say, so you can think about that this will just be P1. And the obj here will also be P1. It will be as if we say P1 equals P1. All right, guys, that's the first checkpoint for you today to make sure you understand. So this is still simple because we don't have any overridden version just yet. Later on, if you got multiple classes presented to you, you have to know which one is going to invoke the default version and which one is going to invoke the overridden version. For now, it's simple. All right? All right, let's now try to, okay, so it's really important for you to understand this line. All right, this one here. So P1 equals P1, true. That's obvious. All right, so what about this one here? This one here would be as if, let me put a star here. The star will be as if we say P1 equals null. It's just that now P1 here is this. And null here is the obj, the parameter, right? So now P1 equals null. True or false? False. It's not null. There's really an object there. All right, let's move on. What about P1 dot equals S? This one's very interesting, right? Here, let's see this. This one deserves a little bit more attention. All right, star, okay? What I said earlier still applies. When you say P1 dot equals S, right? It would be as if, let me put in quote for now. I don't really mean string. I say you can think about it conceptually for now. It would be as if we are trying to compare the references between P1 and the string S. Okay, for now, okay? Again, I put a quote not because it's a string, because you want to treat it a little bit special, okay? And let's now take a look at the P1 here. We know that P1 here is some point V1 objects. And the S over here is some string objects. It seems a bit peculiar. It doesn't seem to be a fair comparison. You're basically comparing orange to apple, right? However, for the equals method, I will say just what you need to know for now. For the equals method, look at the parameter type, objects. That means when you pass an argument into the equals method, it can pass basically anything. It can be a string, can be a refurbished store, can be a log, whatever. It's always going to compare. And what it boils down into comparing will be just their references. So in this case, it's going to be false because they're simply object here and object here, different objects. All right? One thing to note, which I'm going to also emphasize a little bit later. Now, I'm going to explain what I really mean by quote over here. If you try to write this down in another form, if you simply write down P1 equals S, maybe I wouldn't show you on Eclipse today. I'll try to do that maybe next, not next, I mean after reading week, okay? If you try to write this expression over here in Java, concretely, not conceptually. Conceptually, we understand they're comparing addresses. But if you try this line here in Java, Eclipse, not going to compile. Because Eclipse is going to tell you you're comparing something of type .v1 and something of type string. You cannot use the equals operator on two reference variables of different types. You cannot do that. However, for equals method, you can. All right? That seems a bit weird. Okay, let me recap. There is a way to compare orange to apple in Java, which by using the equals method. Because the equals method has this parameter type over here called objects. That means any object you put into as arguments for equals method will be okay. Can be string, can be refurbished store, can be whatever. So when you say P1 equals S, it's going to compile. What it boils down into is more or less comparing the addresses of these two objects. But they're different objects. So it's going to give you false. So this line here is okay. It's going to compile. On the other hand, if you just write down explicitly P1 equals S, it's not going to compile. Because now it's not the equals method anymore. The Java, the Eclipse is going to say you cannot compare them directly, addresses. All right? That's some subtle difference you want to absorb. All right? Let's now move on. Let's now go on to P1 equals P2. All right? So now P1 equals P2, the same type. So now it will be as if we say star, star, star. P1 equals P2. Well, obviously, false, right? Different objects. And what about P2 equals P3? Also false. So it's always calling this default version when you call equals. All right? We're going to do something very similar when we get to the overridden version for .v2. And it's going to be a little bit trickier, but it's not too bad. All right? Any question about this? Yes? Yeah, you may. For example, the question was, can you put an integer? You'll be okay. For example, you might say P1 dot equals 23. It will still be okay, but it's going to be false, of course, right? What Java will do is it's going to treat this as a wrapper class called integer. And this one's there is still .v1. So it's going to be false, but it's going to compile. Okay? Again, you want to really watch out for this parameter type over here. And you may not get 100% understanding about this since we haven't talked about inheritance just yet. But for now, just remember the fact that we got object type parameter means you can pass anything as argument, just anything. All right, any question so far about this? Okay, I hope that's still clear. Oh, sorry, go ahead. Compilation error. Yes. You know what? Maybe I can show you guys very quickly. I think it deserves some very explicit show on the Eclipse. Let me do that right away. For example, if you try the following, if you go to that code example I made available to you, again, we got .v1 here, right? That one there has no default construct, it has no explicit construct, has no explicit equals method here, like what we said last time. And let's go to the tester. And this is something you would like to try too. So, for example, I can add something here. Let's say we already got P1, right? I'm going to add some line here. String S will be, let's say, 2, 3, 4. Okay? And then, if I say P1 dot equals S, there's no red underline. So it's okay. But it's going to be false. And of course, it will be better if I say system.out.println. P1 dot, yeah, you can give it a try, but it's going to be false. On the other hand, we said conceptually in quote, this will be as if I write P1 equals S, right? Let's give it a try right away. Now I'm going to replace this guy here by P1. Rect underline. Let's read it together. Incompatible operand types point v1 and string. It's saying that this operand over here is point v1 type, and this operand over here is string type. You cannot compare them explicitly for their addresses. All right, that's exactly the point. Right? It's important. All right, so I'm going to leave this here, and then. So Jennifer, did I answer your question there? Good. Okay, so let's now move back to some overridden version. All right, so now let's talk about overridden. And I want you to also recall last time, maybe the last final minutes or so, I also showed you on Eclipse, like how you can go to source and generate the equals method, right? So the version I'm showing to you now is basically what's being generated by Eclipse. So now let's take a look at this method very carefully, line by line. Right? It has very important consequence for each line. So we have to understand them thoroughly, one by one. Let's see the overall structure over here. We still have the object class, and that one there has the default version of the equals method, which in the previous case, point v1 is going to use it. Right? But now we have another class called point v2, a different class. But now this class over here now has its explicitly overridden version. So if I just box everything over here, so this is a overridden. Or you can think about it as like a redefined version. Equals. So what's the consequence? The consequence is now, as soon as I say some objects of type v2, and I call the equals method on that, now I got two choices. Either it would be this default version here, or it could be this overridden version here. It turns out it's going to be this version that's going to be called, if there's one. If there's no such overridden version, the default version will be called, like in the previous case. Right? So that's a clear picture you really want to get first. All right. Let's now go over the definition line by line. Okay? Let's now take a look at line number 1 over here. And don't forget, equals method is an accessor. It's always going to return the Boolean. All right, so we'll talk about 4 different cases. Case number 1 that we're going to talk about now, and then case number 2, which we'll see later. Case number 3 over here. And then this whole thing here is case number 4. All right, just to let you know. Let's talk about case by case. Case number 1. We say that if the context object this is the same objects, meaning that they share the same address, as the OBJ that's passing as arguments, then return true. That means they're the same objects. Of course, they are equal. So phase number 1 is the easiest one. All right? And then we'll see some example right away. Just bear with me. I'm going to write some comments over here for you. So this one is saying this. If the context object this is the same objects as the input parameter OBJ, they are equal. Because they're simply the same objects. It will be, diagrammatically, it will be something like this. So we are basically talking about the same point v2 objects, and we got this pointing to it. And also we got OBJ pointing to it, just the same objects. Right? This is case number 1. Let's see some example right away. Okay, I'm going to go to here. All right, so now we're going to focus on this line here. This is the line we just spoke about, right? And here is some example code. And we still have our friend S over here, right? 2, 3, right? We'll worry about that later, okay? So we got P1, P2, P3, right? P1, P2, and P3. They're of type V2, right? So let's now fill them out. So we got 2, 3, and then 2, 3 over here, and also we got 4, 6. And let's only look at this line here. That's all we need. Oh, sorry, not yet. Sorry. Quick check. P1 equals P2. False, right? Easy. P1, P2 equals P3. Also false. Right? And now let's look at line number 7 carefully. What's going to happen when we say P1 dot equals P1, right? Now, in this case, P1 over here is the context objects, right? Let's look at this. P1 over here is the context objects. And we know that it's pointing to a point V2 objects. How do I know? If you look at the diagram, exactly here. It's a point V2 object, right? So we know that the version that's overridden for the equals method in point V2 is going to be invoked. The overridden version of equals in point V2 will be invoked. This is a very important point to see, to decide which version, right? Whenever you want to decide which version of the equals method should be called, you should really look at your tracing diagram and see, now for this context object P1 over here, which object it is pointing to? In this case, point V2. In that case, it's going to go to point V2. Do you have an equals method there? Yes, it does. Exactly here. So we're going to use this version here rather than this version. That version there is not relevant anymore. All right? So let's now try to trace it. So the way to do it is we're going to say P1 dot equals P1. And then we're going to go execute this method here. So now the this will just be replaced by P1. And the OBJ is also going to be replaced by P1. So you'll be as if we said P1 equals P1. So it's going to return true. So the result for this one here is simply true. This is a very simple case because you're basically comparing two objects that are actually storing the same address, right? Two variables storing the same address. I'll give you another example here. What if we say we add a new line here, hypothetically? Let's say between line number 4 and line number 5, okay? Over here. I'm going to put one more line. If I say point V2, let's say P4 equals P1. We know that that one there is going to make sure P4 also points to this object here, aliasing. And then, if I do in the next line, if I say P1 dot equals P4. Now, how is this line going to work? All right, similar. Let's now take a look. This line is going to work as follows. So P1 over here is going to be still the this, right? Still P1. And P4 over here is the OBJ. So OBJ, the parameter would not be P4. So P4 over here. So it will be as if we say P1 equals P4. And now, are they pointing to the same objects? Indeed. So this one is going to be true. That's just another example. So whenever you say something that equals something, if those two things are the same objects by aliasing or just the same variable, then of course they are equal. That's phase number 1. I see some of you are smiling. Does that mean it's fun or confusing? Or I presume you're okay, right? This is maybe the simplest case. Yes? Yes, exactly. So the reason I'm showing this is whenever you're passing, let's say, whenever you say P1 that equals something, if these two are really the same objects, sharing the same address, the first statement here is just going to catch it and return true, because you know you're comparing two objects that are really the same, right? That's phase number one. So that's why I put it up at the front. Yes?
So what's the point of overriding the method? It's already implicitly...
If you only, yeah, the question was, what was the point of doing an overridden version given that we're also comparing addresses, right? But remember, this is only phase number one. We still got phase number 2, 3, and 4. So phases number 2, 3, and 4, they are not really covered in the default version of the equals in the object class, which we're going to see. So phase number one here, just to make sure whatever the default version can do, we can do. We can do something even more. Okay. Good question. Robert?
For the overriding, I don't know if it's something to do with the characters, but don't we need different parameter names?
Not really. So I would say usually when you try to override a method, that means you're basically copying the same header that's from the superclass, and then you try to copy the header, but you're going to do something a little bit different in the implementation. That's what it usually means.
Is that like you always have to change the parameter?
No, you don't have to. So as you can see here, the parameter here, the equals here in the object class, and the equals method in the point v2, they have the same parameter objects. And also return type is also Boolean, so they are the same. That's what we call overridden. So the header of the method, including return type and parameter, should be the same. Otherwise, you wouldn't be called.
Is that for constructors only when we have, like, if you want multiple constructors, you have to...
Yeah, then in that case, it wouldn't be called overridden. If you're already changing the parameters, you're not really talking about the same method anymore. That's from the superclass, so it wouldn't be called overridden. Overridden means I'm talking about the same method. That's from somewhere, but now I'm changing its implementation. Yeah.
The overriding is different than overloading.
They're different. Maybe that's what you were confused. All right, guys, little exercise for you. I'm not going to tell you the answer, but you should really study for that. Method overloading versus method overriding. I believe double D. Or you can think about it's like a redefinition. That's how I would like to think about it. They are different things. How are they different? Well, you got to look it up. We talk about both. All right, that's for you to find out. All right. All right, any question about phase one? If no, let's now move on to phase number 2. And let me just go back there. Okay, phase number 2. Phase number 2 is to say if I'm able to reach this line, let's say this. One thing you can observe right away is this. Because you can see that this if statement happens after the previous if statement. Right? You can see this condition here happens after this condition is being checked. So if we are able to reach this line without returning true, what does that mean? That means the negation of this must be true. They are not the same objects. Right? That's an easy observation. Reaching this line, reaching this phase, how about that? Means it is not the case that this equals objects. We'll see that in the example, but this is something for you to observe right away, logical. Because this and obj, they are different objects, different addresses, but they might still be equal in some sense. So that's why we still go on to compare them. We still got a chance to return true at some point. All right? And what does this second phase really mean? We say that if the parameter over here happen to be null, and we're going to return false. What does that really mean? It is saying that if we're comparing P1, let's say if we call P1, this is to say the following. When you say P1 dot equals, let's say something, let's say X. And we're saying that if this X over here, which is basically this OBJ over here, right? If this is actually equal to null, the equality is just going to be false. This is what we are saying. All right? Now, question for you. Why did I not have anything to do with, what if this is also equal to null? In that case, I got null equal to null. Then it should return true. That's my question for you. All right? Now, I'm going to highlight this whole thing over here. Question for you. What if this equals null is also true? That means, can I have the following line of code? If I say if OBJ equals null, and then I'm going to say further analysis over here. I'm going to say something like, if this also equals null, I'm going to return true. Otherwise, that means this is not equal to null. Then I'm comparing not null with null. All right, this is very important for you to think about, right? That's my question. This will be something alternative. And this will be return true, and this will be return false. Oh, maybe I can make it a little bit better. All right, so here's my question for you. Line number 1, line number 2, line number 3. Does it really make sense if I replace this line over here by this block over here? I'm saying the following. If the context object this and the parameter object OBJ, if they're both null, in which case it's going to reach this line here. Null and null, I should return true. On the other hand, if OBJ is null, but else part means this is not equal to null, in that I return false. If you compare null with not null, it should be false. Is this code here really logically sound or logically making sense? I can tell you that if you put this program in the code, it's going to work. But it shows that you got some conceptual misunderstanding about how things are happening. Anybody? Anyway. You're saying that if both of them are null, especially if this is equal to null, I wouldn't reach that block. What do you mean? I wouldn't reach that block.
Because the previous statement is comparing both of the objects, and if both of them are null, then it would return true then and there, and it would go to that block.
Okay, what you're saying is, okay, I like your answer. So your classmate is saying that in the case where OBJ and this are both null, in that case, we would have reached this line over here and say null equals null and return true. I love your answer, but sorry, that's wrong. Sorry. But you're getting somewhere. You're getting very close. Anybody?
Can we call a method on a null object instead?
You're getting somewhere, okay? So the answer is, if you got both being null, you cannot even reach the body of the implementation. Because, imagine this. If P1 here is null, X here is also null, are we going to reach this line ever? Not really. As soon as you try to call a method on some null objects, you got null pointer exception right away. You're not even going to reach this line here. All right? So having this block over here, it just returns them. You don't even need to have a worry about if this can be equal to null. You don't have to. So guys, it's a very insightful discussion here about why we are not doing this equals method another way. All right? Make sure you really got this point here. All right, I'm going to make a note here. There's one here. So what your classmate was saying about this here, it would have reached this line. It's a very good answer as an intermediate step. But my point is, you're not even going to reach that line. Because if P1 is already null, you're not even going to execute the body of the implementation. That's the issue. All right? Think about it. So now I'm going to put, let's say, star here. Okay, star. Logically unnecessary. Because if this equals null is true, that means null pointer exception would have occurred. I would say this conclusion here is so important to know why having another alternative definition for that is not logically correct. All right? Make sure if I ask you ever to explain why that block over there at the bottom there is not appropriate, this will be something I'm expecting from you. All right? That really shows your understanding about what's going on. All right? Let's now take a look at one example here. All right? Let me now go back to phase number 2, which will be here. Okay? Now, let's now move on to this line. Everything else is the same. So let me just fill out the value quickly. We got 2, 3, 2, 3, and 4, 6. All right, the same as before. And now, when we do this guy here, line number 8, P1 dot equals null, right? That should be easy to see. So now, when you see execute over here, when you execute this line here, this equals obj, right? So P1 will be this. And null will be the obj. This will be null. So when you execute this line, it will be as if you say P1 equals null. That should be false. So you don't really get to this line, right? So this will be bypassed. And then you go to the second phase over here. Obj over here is actually null. Now, if you compare null equals null, true. So we're going to execute this line. It's going to return false. Return false because right now we're comparing basically P1 over here with some null value. They cannot be equal, right? Return false. So that's an example right away. If you're comparing some object that's not null with another null value, it's just false always. There's no way they're equal. So these are the two phases. Any question about two phases? All right, so now what's going to be left will be phase number 3 and phase number 4. And for these two phases, I need to touch upon a little bit about something called static versus dynamic types. But I would suggest we do that after a very short break. Okay? But before the short break, I'd like to give you guys some magic trick. Okay? That's what I usually like to do right before the reading week. I'll tell you what I want you to try maybe afterwards. And to do this magic trick, I need 2 assistants. One boy and one girl, let's say, from your audience. Anybody would like to volunteer? Just raise your hand. Anybody? Or I can point to somebody. It's fun, don't worry. Come on, one girl and one boy. All right. Coming up, please. All right. And just to really make sure it's completely random, I need assistant 1, assistant 2 to do 2 different things. You guys know rock, paper, scissors, right? Yeah. Okay, rock, paper, scissors. The winner will take assistant 1. Just one.
1, 2, 3, shoot. 1, 2, 3, shoot.
Good. Okay. assistant 1. Assistant 1 and assistant 2, okay? Now, assistant 1, what I got is, I got some program here, magic program. I'm gonna run it as Java application. Over here. Give me a moment. There we go. And now the program is running. All right? It's always going to be running before the magic trick reveals. Right? And now, assistant 1, what's your name?
Midland, M-Y-C-H-A-E-L-Y-N-N.
All right? So this is how this is going to work. You know poker, right? Okay? So now, assistant 1 is going to somehow choose a card from here, and she will let everybody know except me. I'm going to step down outside the classroom for just a few seconds. Don't take too long. And Thomas, assistant 2, your job is when she's done choosing the card, ask me to come in. Okay. All right? And maybe, I don't know, you can write on the board, or maybe you can just highlight it quickly to let people know which card you have chosen, but make sure unhighlight it. Okay. All right? You can see the program is still running. All right? All right. Don't take too long, please. Thank you. Make sure you don't let me see. I didn't see anything. Don't let me see it. All right, done, right? Everybody knows what the card is? Okay, now let me clarify some terminology, right? It's important, otherwise the magic wouldn't work. Okay? So now, let me remind you guys. So the question is going to be like, all the 3 columns, right? You got to tell me which column it is. Okay, column 1, or column 2, or column 3. That's all I need, all right? Now, I'm going to ask you 3 simple questions. Which column does your car sit? First, okay. Well, vertical, right?
Yeah.
1, right? Question number 2, I shuffle the card. Which column? Everybody agree? 3? Okay. Okay. I shuffled again. Second, 2, okay. Now I know what a car is.
Whoa.
Magic! Thank you so much. Thank you so much. All right, so let me tell you why I'm doing this. I'm not doing this randomly, right? All right, it's fun. But guys, my point is, what's happening here is not really just magic, it's math behind the scene. Let me tell a little bit of history about this magic trick. Do you guys know Professor Jeff Edmonds? So he was a professor here already when I was a student back in 2004. Maybe you were not even born around that time. I was taking this course called 3101, Algorithm Analysis, and then I remember in Patrick Science Building, he showed us some physical poker to do this trick. And he was trying to illustrate some idea called looping variance, which you guys will get. And when I started teaching, I thought maybe I can turn that into a Java program. And maybe that's something even more cool. So here is what I want you to try. Again, this is something, no bonus, no extra points, completely out of your curiosity. Okay? I'm going to send this link to you. The whole thing is based on something called, like a card trick for kids. Right? You can go to that site there. Now, here's the challenge. Maybe during the reading week, if you want to try to sharpen your programming skill a little bit, to really program this trick, it's not that trivial. You're going to use some array, maybe some list. You're going to use nested loop. You're going to use quite a bit. You can also try to make it more OO by creating multiple classes. And if you ever finished the puzzle, like how I illustrated, come to my office hour and show it to me. And then I'd like to give you some feedback about your design. All right? Again, no extra mark, no bonus. I just want to see how many of you may decide to show me your extra efforts. and then we can have some interesting discussion. Okay, that'll be it. Okay, now why don't we take a 2 minutes break, and then we'll go back to equals method. Alrighty. Okay, so the next two phases will be, you will see something like get class and something like typecasting, right? So to really understand these two things thoroughly, we'll definitely need some knowledge when I get to the inheritance lecture. But I thought it would be a good idea just to give you some very intuitive definition about the various concepts over here. So let's do that. It's not too bad. But I guarantee once we have gone through the inheritance lecture after the reading week, this will make even more sense. But I'll try my best. Right, this small example here, I'm going to illustrate to you three things. There is something called there's something called static type, dynamic type, and typecasting. Right, so these are the three things you are going to master by the end of the course. But you can do it just today. Right, intuitively, they are not too bad. Right. And definition, I put down something here. Let's read it together, and then I'll use an example to illustrate to you. What does it really mean to be the static type? Whatever reference variable you have, once you declare its type to be point v1, person, whatever, it's going to be the static type. It can never be changed. Okay? That's static type. Dynamic type always requires some tracing. Okay? And so that means whenever you try to have maybe, say, P1, is currently pointing to some object over here, the title of the box is the dynamic type. Meaning that if I say P1 rather than pointing to this, it's now going to point to another object here with a different title. That will be the new dynamic type. That's how you understand dynamic type. It's called dynamic because it can change. And static because it cannot change. Okay, static type versus dynamic type. Now we're going to see example. And typecasting over here is also interesting. Typecasting simply means you're going to write some expression there with the parentheses, the syntax there, and it's going to create some expression with some desired static type. Right? But let's see example here. So these are the short definitions, but we just need example to help us to visualize what's going on here. And for simplicity, let's say we got two classes here. We got C1 and we got C2, separate classes. Let's say in C1, we got only M1. And for C2 here, we only got M2. All right, that's important to know. We got two classes over here, M1 and M2. And we're also going to have object class into play. It is important to say the following. The object class, which we have no control over, it's been predefined there in the Java API, does not declare or define M1 and M2. So that means this M1 over here is specific to C1. N2 over here is specific to C2. Right? That's an easy clarification, right? Just to say that. You can always think in this way. Whatever new class you're introducing, the method you define in your own class, if that's not overriding, that method there always is only specific to the class you're declaring. They are not specific to, for example, objects. Object simply doesn't know you have that method. All right? This is important. And one more thing to say. Whenever we got a static type, what is so important about static type here? I'll put it here. The static type determines the method that's applicable or callable. I say applicable to the context objects. All right? It's a very precise definition. I'm saying that whenever you're making a method call, let's say obj dot some method, how does Java compiler know whether they should compile or not for that method call? The number one thing you look at is what is the static type for the context objects? If that static type there declares the method being called, then it should compile. If it doesn't declare that, it should not compile. It's that easy. But let's see. Let's now go over the code one by one. Now we go line number, let me see, line number 1 here. All right, so we got O1, and then it's going to have some box over here, and then C1. One thing to note right away, let's apply the concept of a static type and dynamic type. The declared type over here, C1 and C2, which we're going to see, so these are the static type, ST. Whenever you're using a new keyword, it's a new dynamic type. C1 and C2, right? So these are the dynamic type. So now if we talk about O1 over here, what's its static type? C1. What is its dynamic type? Also C1. So far what you have seen, maybe in your first year and up to now for the course, static type and dynamic type, they always match. But they don't have to. All right, that's important. Let's now go on. And when you got this line over here, line number 2, and then O2 is going to point to another object over here, and C2. Again, static type for O2 would be C2. And dynamic type for O2 would be whatever that's being created, C2. All right? Let's now just always remind you that C1 and C2, the title of the box, so these are the dynamic type. All right? As soon as you change the arrow to something different in the box, the dynamic type might change. Let's do something simple. If I say O1.M1, does it compile? It does, because the way Java looks at, the compiler looks at this is like this. O1 has the static type C1. Does C1 have M1? Indeed, it does. Checks. That's how it does. All right? What about O1.M2? Also fine. O1, static type C1, which does have M1. Sorry, M2 here, right? Check. And similarly, what about O2.M1? Oh, beg your pardon. I did say something wrong. Let me say it again. Okay. This one here is okay because O1 static type is C1, which does have M1. Good. But now, O1 has a static type C1. Does it have M2? No, it doesn't. It's only for C2. So this will not compile. Because the static type of O1 doesn't declare M2. That's the precise reason for that. And that's exactly how the Java compiler is encoded. All right? Not too bad. And then similarly, if you try O2.M1, does it compile? Well, O2 has a static type, C2. Does C2 have M1? No, doesn't compile. What about O2.M2? Good, right? O2 static type C2, which does have M2, right? That's good. So also good? All right. So far, I think it's pretty much what you have learned. But I'm just trying to give you the precise reasoning about how to decide whether something should compile or not. And let's now bring object class into play, and we'll see the need for casting. All right? I want you to look at this line here with only the declaration. When I declare O3 to be of type objects, I'm saying that the O3 has a declared or static type objects. So O3 over here has the static type objects. And we know that object class has, for example, equals method has very minimum stuff over there. But object class definitely does not have M1 or M2. All right? Let's now do something here. If I say O3 equals O1, all right, so O3, let me put O3 here, okay, O3. And don't forget, its static type is objects, right? O3 equals O1. After this line, what will be the static type of O3? Remember, static type never changes, right? So static type, after this point over here, the static type of O3 remains to be objects. What about dynamic type of O3? You got to look at the box, C1. That's really why tracing is important, because in order to figure out dynamic type, you have to do tracing, right? Not so bad. And at this point, let's do something here. If I say O3.M1, does it compile? Well, O3 here is really pointing to some C1 object, which does define M1. Why should it not compile? Should it or should it not? What was the principle? In order to check to see whether the method can be called, which type do we look at? Static type. All right? So now O3.M1, it turns out, is not going to compile, because the static type of O3, which is objects, does not have M1. All right? It is important, right? Let me just say one more thing, and I'll take a question. Let me say one more. Similarly, if you try O3.M2, also it's not going to compile, because O3 has a declared static type, objects. Object does not have M2, so also doesn't compile. Question? The casting, we'll get there. Don't worry. Yeah, we'll get to casting. Yes. Which is next? Okay. Yeah, so far the principle is very important. Whenever you decide whether a method call should be compiled, look at the static type only. Doesn't matter what dynamic type it is. Doesn't matter. All right? And now, let's now see how the casting may help the issue. All right? Let's look at this method here. It might look very peculiar to you, because here you can see O3 indeed is calling a, O3 here is indeed pointing to a C1 object. C1 definitely has M1. I must be able to call M1. Gotta be. But I cannot break the principle. So the only way around is to create an expression or alias that is going to point to this object here, but that alias must have a different static type. That's kind of the reasoning for using typecasting. All right? Let's see how that can be done. Now, if you look at the expression here, if you look at the expression here, there we go. This is a casting. You can see the parentheses, and I put C1 inside, and O3. This effectively creates an expression that has the static type C1. As soon as I've done that, that expression there is able to call M1. All right? Let's now take a look. I'm telling you basically about 80% of the story, but there will be another remaining 20% which I cannot tell just yet. That one we have to wait until inheritance. But for now, just focus on the example I'm telling you. If you look at this part over here, this is basically an expression. An expression of static type C1. Now, let's go back to the principle. If you actually got an expression of static type C1, can you call M1? Yes. And then, if you got this one here still, now, if you got an expression of static type C1, can you call M2? No, you cannot, because C1 doesn't have M2. All right? You might be wondering about one thing, which maybe some of you are wondering already. What if, just for now, okay? In order to make this guy work, right, can I do something like this? I can try to say I'm going to cast O3 into C2. And then the whole thing is now static type, and then I can call M2. All right, you might be wondering about that. All right, just in case. This one here, for now, to let you know, that one's not going to compile. You cannot randomly cast something to something else. There's got to be some inheritance relationship you have to follow. So I would say, in case of wondering about this one here, don't worry for now. Okay? The way you're going to do casting before we cover inheritance is just about the equals method. But I just want to let a little bit more. Okay? This one here, I would say don't worry for now. All right, let's now finish the example here. And then let's now do another line here. Let's say O3 equals O2. Right? O3 is now going to point to O2. Now, let's double check. After this line, what would be the static type of O3? That's question 1. And what would be the dynamic type of O3? Question for you. Guys, what will be the static type of O3? Object. Never changes, okay? Whenever I ask you static type, always just go back to where it is declared, right? Objects. What about dynamic type for O3? C2, because now pointing here. That's why it can change. You can see the static type remain the same, but dynamic type changes from C1 to C2, right? So the way for you to change dynamic type for a reference variable is by doing variable reassignment, all right? And let's now do a little bit more casting here. So now if you try, let's say, O3, I'm now casting that into C2. So now this expression has a static type C2. Can I call M1? Oh, no. C2 has no M1, right? Be careful, right? So now you cannot. The same reason. And what about here? This one here, casting O3 into C2. Right? C2 is now the static type for the expression. Now, can we call M2? Yes. I think this example here is very valuable because once you understand what's going on here in this example, then I think you understand about 80% of what's going on. And then when we go back to phase number 3 and 4, it'll be much better. Otherwise, if you don't kind of have some basic sense about static type, dynamic type, and casting, it's very confusing to see phase number 3 and 4. Right? I think this will help. But I'll take question. Oh, okay, quite many. I like it. Good. How about start with the boys here?
If we typecast, like, for example, O3 to C2, can we store that into another object?
So what you want to do, for example, can you say it again?
For example,
O3?
yeah, like typecast it into C2, can we store it into like an object with static type object, or that?
Okay, so here, if I understood correctly, when I have this expression over here, I'm creating a new expression. That expression there has nothing to do with O3. Let me put it this way, okay, to make it more precise. Let's say this expression over here, let's put it in purple. Think about this expression here is more like an anonymous reference in the sense that the purple one is actually going to point to wherever O3 is pointing to over here. The only difference is this. For this O3 guy, the static type is objects. For this anonymous reference guy, its static type is C2. That's the only difference. But they're really pointing to the same objects. So now you want to start having this kind of a separation between, when I say there are two references pointing to the same objects, their dynamic type is the same because the same objects. However, their static type might be different, which is going to impact about using method call on those two references separately. That's the main insight. Okay? So this guy here has a static type C2. All right? Whereas for O3 over here, it has a static type objects. So if I Oh, the cast expression, that's something we'll see when we go back to phase number 4. You will see that. Yeah, go ahead.
So what I can see here is we have to have the same dynamic type in order to cast it.
Okay, okay, you make some observation there about casting. I would say yes. For now, okay, that's a good tip. Guys, I would say for now, whenever you're wondering about if I got some object reference here, what type can I cast it to? For now, okay? Always make it cast to the same dynamic type. That's good. I'm glad you mentioned that. Okay, here's a tip. Whenever to cast, let's say n objects, always cast it to its dynamic type, the same. However, once we go to the inheritance lecture, it's not just the same. It depends on some inheritance hierarchy, but we'll get there. For now, it's good. All right, any more questions? Yes, oh, sorry, I forgot about you too. How about you first, and then I'll go Sama. No, O3, no. Remember when we got to this point here, when we got to this point over here, O3 has been reassigned to where O2 is pointing to. Oh, you mean this one here? O3.M1 over here? It's because O3.M1 here is without any casting. So now O3 by itself has a static type objects. Object does not have M1, so that's why it cannot compile. No, we don't refer to O1. So here we're still talking about O3, the static type only. Whenever we talk about method call, you only look at the static type. All right, any questions? All right, we got 5 minutes. I'll suggest let's use the 5 minutes to go over phase number 3 and 4 very quickly. And now you'll be ready to do equals method at least. Struggle through this content a little bit over the reading week. And then when we come back, we're going to do the remaining part of the lecture. Okay, 5 minutes or so. Let's now go to phase number 3. All right? Phase number 3 here is saying the following. This.get class not equal to obj.get class. Okay? What does get class do? Now you can understand. Get class tells you what the dynamic type is for that object. All right? Get class over here simply tells you the dynamic type of this. Versus when you say obj.get class over here, it's going to give you the dynamic type of obj. What are we saying? We are saying that if we're comparing two boxes with different titles, equal should be false. Okay? Conceptually, it goes like this. If I got this over here, and then it's pointing to some objects, and then the title is maybe question mark, for example, and then we got, how about this? Let's say triangle, and then we got, let's say obj, another object over here, and that one there has maybe like a star. All right? So this guy here is simply saying if this guy and this guy are not the same, return false. Okay? And we'll see an example. If they are not equal to, and then we're going to say false. All right, let's see example right away. And let's now move on to here. Okay, maybe this will be the last example we can do, but that's okay. Now let's take a look. Here we got this. This one is pretty easy, right? You can think about what's happening here is, so S is basically the string. You can think about S is pointing to some string objects. Let me now be more precise for the drawing. And then this will be string class. All right? And now we say P1 equals S. All right, let's now execute very trace down for the equals method. Now we got P1 and S. So obj will be S, OBJ will be S, OBJ will be S, and OBJ will be S. And also this will be P1. This will be P1, and this will be P1. Okay, we got all the replacement done. All right, let's now trace one by one. P1 equals S. False, not the same address, right? Bypass this, bypass. String equals now. Not really, because you do see some object here, right? That one we also bypass. Now, get to this line here. Now, P1.getClass is going to give you the dynamic type, point v2. Versus S.getClass string. Now, are these two classes the same? No. In that case, we simply return false. Because now we got not equal to, right? Because they are not the same dynamic type, so they are not equal, so we go to this branch. Right, any question? Okay, I'll take 30 seconds about what you should really try to understand before the reading, during the reading week. All right? Now, what you want to realize is, if I only have obj as is, based on the example we studied, if I say obj.x and obj.y, is it going to compile? Because obj, remember, its static type is declared over here, objects. Am I able to invoke x and y over here to compile without casting? That's a question for you. So I think you guys are ready to really understand this last fragment of code based on the example. So make sure you really go over up to phase number 3, and to understand phase number 4, you can go over this example once more. All right? I'll see you after the reading week.